January 17, 1944. A bitter wind cuts across the frozen fields of northern France. Mud clings to boots, teeth chatter, and the distant rumble of engines shakes the frosted earth. In the middle of a shattered village, a small group of German engineers kneels beside a captured M4 Sherman. Their breath fogs in the cold air, fingers tracing the contours of its steel hull, eyes narrowing at every bolt and spring. The tank sits silent, yet it seems alive. Tracks sag slightly under the weight of winter grime, yet its chassis appears unyielding. One engineer taps the suspension arm. It bounces back and again. Confusion flashes across their faces. How can a machine endure constant bombardment, mud, and shellfire yet keep moving? Nearby, abandoned helmets and spent shells litter the ground, silent witnesses to the struggle that brought this machine here. The Sherman's engine hums faintly. Almost defiant, a reminder of a relentless force the German army has yet to fully comprehend. It is in this frozen field that a critical realization will begin, one that could redefine armored warfare. By the early 1940s, the Second World War had transformed the world into a theater of steel and fire. Across Europe, mechanized armies were testing the limits of human endurance and engineering. Germany had stormed through Poland, France, and much of Western Europe with panzer divisions that seemed unstoppable. Yet the Allies were not idle. In the United States, war production had begun on a scale the world had never seen. Factories churned out aircraft, artillery, and most crucially, tanks. Among these, the M4 Sherman would emerge as a cornerstone of Allied armored power. The Sherman was not the largest or the most heavily armed tank of its time, but it was versatile, reliable, and produced in staggering numbers. By 1942, the U.S. was delivering dozens of Shermans every week, sending them to British and later Soviet allies under the Lend-Lease program. Its design prioritized mobility, maintainability, and a balance between armor and firepower. Unlike the German Panther or Tiger tanks, which required careful handling and constant maintenance, the Sherman could endure the roughest conditions and keep moving. German armored forces, by contrast, faced increasing challenges. Early war successes had relied on speed and concentrated force, but as the conflict expanded, logistical and technological pressures mounted. Panthers and Tigers were superior in firepower and armor, but their complexity made them vulnerable to mechanical failure and fuel shortages. Every recovery mission, every broken-down tank, was a drain on resources the Germans could scarcely afford. When Shermans first appeared on the battlefield in North Africa and later in Sicily, German officers noted them almost dismissively. Light American tanks, they said, quick but fragile. Yet even in the harsh deserts of 1942, Shermans demonstrated an unusual resilience. They could traverse broken terrain, survive minor hits, and return to their units with minimal repairs. Unlike their heavier counterparts, they did not require specialized crews or constant technical support. The battlefield itself had become a testing ground. In Tunisia, where the Allies and Axis clashed in a war of attrition, engineers and commanders on both sides learned to respect machines that could endure the unthinkable. German intelligence began collecting data on Sherman armor and mobility, sending reports back to Berlin. These reports were filled with cautious observations, noting that while a Sherman lacked the raw power of a Tiger, it often reappeared in unexpected positions, seemingly immune to the chaos around it. By late 1943, the Sherman had become a fixture in Allied planning for the invasion of Europe. British and American forces were training crews in England, rehearsing armored advances across fields, villages, and hedgerows that would soon define the Normandy campaign. Every report reaching German headquarters warned of one emerging problem: sheer persistence. Tanks that should have faltered under continuous fire seemed to maintain operational readiness with almost mechanical determination. For German engineers sent to analyze captured Shermans, the challenge was immediate and technical. They had been trained to assess armor thickness, gun caliber, engine output, and suspension systems. Yet when confronted with a Sherman under realistic field conditions, they discovered anomalies. Its suspension, a seemingly simple arrangement of springs and bogies, absorbed terrain shocks without failure. Tracks remained aligned under punishing loads. Components that might seize on a Tiger under strain kept moving with minimal lubrication. Each test, each inspection, hinted at an engineering philosophy foreign to German designs: durability and simplicity over brute force. This was the moment the German army first began to recognize a hidden strength in the Sherman. Not in its cannon, not in its armor, but in its relentless ability to keep moving, to keep participating in the fight long after other machines had failed. It was a subtle but profound difference, one that would have consequences on battlefields stretching from Italy to Normandy, from the frozen fields of France to the dense forests of Germany. The frozen field where the engineers now crouched in early 1944 was a culmination of these developments. Each scratch on the Sherman's hull, each dented fender told a story of prior skirmishes, of shellfire, of mud-filled tracks, of sustained movement over terrain that would immobilize other tanks. The engineers' skepticism was turning into astonishment. It was clear that understanding the Sherman required more than a visual inspection. Its strength lay in the philosophy of its design, a philosophy rooted in endurance, maintainability, and operational persistence. This realization would set the stage for examining multiple perspectives: the human experience of its crews, the tactical advantage it provided, and the technological ingenuity that confounded the enemy. By 1943, Allied planners were preparing for an even larger confrontation in Europe. The lessons learned in North Africa and Sicily had shaped operational thinking. Speed, coordination, and mechanical reliability were just as crucial as firepower. The M4 Sherman, now entering mass production in several variants, had proven itself capable of meeting these demands. Its medium armor and 75mm gun were sufficient to engage most Axis forces at the operational level, while its suspension system allowed rapid movement across rough terrain, a feature German engineers would soon scrutinize with increasing concern. The theaters of war highlighted the Sherman's versatility. In Italy, the mountainous terrain and narrow roads tested armored mobility. Shermans could traverse steep inclines, cross stone bridges, and navigate destroyed roadways without the frequent breakdowns that plagued German heavy tanks. In the hedgerows of Normandy, where armored advances were slowed by thick vegetation and sunken fields, the Sherman's suspension allowed it to walk over obstacles, maintaining offensive momentum when heavier German tanks became bogged down. German observers, meanwhile, were documenting each encounter meticulously. Captured Shermans became case studies. Engineers stripped tracks, measured torsion bars, and tested suspension arms. What they discovered was counterintuitive. Unlike German designs that emphasized raw armor or firepower at the cost of mechanical simplicity, the Sherman's vertical volute spring suspension, VVSS, absorbed shocks from uneven terrain with remarkable efficiency. It distributed weight evenly across its wheels, reducing wear on tracks and minimizing the likelihood of immobilization. Operational reports highlighted another critical factor: maintainability. Shermans could be repaired quickly in the field. A broken track could be replaced by a trained crew within minutes, often without specialized tools. Engines ran on standard gasoline, unlike German tanks that relied on scarce high-octane fuels. Every feature contributed to a machine that, in the words of one German intelligence report, never stops moving under conditions that would disable others. By early 1944, these mechanical characteristics were more than curiosities. They were strategic advantages. In the lead-up to Operation Overlord, Allied commanders planned armored thrusts that relied on sustained mobility, trusting that Shermans would carry infantry and artillery support across the European countryside, despite enemy fire and natural obstacles. German panzer divisions, aware of the numbers and resilience of these tanks, faced a mounting dilemma. Even with superior firepower, the mechanical reliability of the Sherman threatened to outpace German response times. The psychological impact was equally profound. Soldiers and engineers alike began to notice a pattern. Shermans that should have been immobilized, abandoned, or destroyed were continually returning to combat. This persistence challenged German assumptions about armored warfare. It forced commanders to reconsider tactics, relying less on tank versus tank engagements and more on ambushes, artillery, and coordinated counterattacks, measures intended to neutralize the Sherman's mobility advantage. The frozen field of northern France in January 1944, where German engineers inspected a captured Sherman, was a tangible representation of these accumulated lessons. Each dent, scratch, and mud-encrusted suspension component told a story of resilience. The engineer's task was clear. Understand why this machine, lighter and seemingly less formidable than German Panthers or Tigers, could survive and advance where others faltered. Their analysis would reveal a simple yet profound truth. The Sherman's strength lay not in dominating a single encounter, but in enduring countless engagements, maintaining operational effectiveness, and ultimately, shaping the battlefield through relentless movement. This understanding would form the foundation for exploring multiple perspectives: the human experiences of crews, the tactical advantages for commanders, and the technological insights that confounded German engineers. Each angle would illuminate how a seemingly ordinary tank could redefine the conduct of armored warfare. Inside the Sherman, life was a constant negotiation with danger. Crews endured cramped interiors, rattling engines, and the deafening roar of gunfire. For a tank commander, every decision mattered. Speed versus caution, exposure versus cover. The Sherman's reliability became a lifeline. Tracks rarely broke under normal conditions. Engines started even after hours of inactivity, and suspension absorbed shocks that would have thrown other crews into chaos. Soldiers learned to trust the machine instinctively. During the Italian campaign, crews reported crossing rubble-strewn streets and collapsed bridges that would have immobilized heavier German tanks. The Sherman's endurance allowed crews to focus on tactics and observation rather than survival of the vehicle itself. Over time, this reliability fostered confidence and cohesion within units, turning the Sherman into more than a tool of war, a partner in survival. From a tactical standpoint, the Sherman's mobility reshaped how armored warfare was conducted. German panzer divisions relied on concentrated firepower and ambush tactics. The Sherman, though less powerful per individual tank, could outmaneuver static defenses. In Normandy, when hedgerows blocked progress, crews found ways to cross them without disabling their vehicles, often using ramps created by other tanks or commandeered vehicles. The suspension system, combined with a relatively light weight, allowed the Sherman to maintain momentum over uneven terrain where a Panther or Tiger would stall. Commanders could plan rapid thrusts, exploiting gaps in enemy lines and coordinating with infantry and artillery. In essence, the Sherman transformed operational planning from a rigid confrontation to a dynamic chessboard of movement and positioning. The heart of the Sherman's resilience lay in its vertical volute spring suspension, VVSS. German engineers, accustomed to more complex designs like torsion bar suspensions in Panthers, initially underestimated its simplicity. The VVSS allowed each road wheel to move independently, distributing shock across the chassis and reducing track derailments. Springs could absorb the impact of shell craters, rocks, and uneven ground. Maintenance was straightforward. Replacement parts were abundant, and repairs could be conducted in the field with minimal tools. This system contrasted sharply with German heavy tanks, which required specialized workshops and skilled technicians to maintain operational readiness. The Sherman's design philosophy was clear: endurance over raw power, simplicity over complexity. This combination of features ensured that even in prolonged engagements, the tank never stopped moving. Allied commanders quickly realized that the Sherman's reliability allowed for audacious operational planning. Officers could order sustained advances without fearing mechanical breakdowns in the midst of combat. The mobility of entire armored brigades meant that supply lines, infantry support, and artillery coordination could be synchronized more effectively than with slower, heavier German tanks. Leaders like General Patton leveraged the Sherman's endurance to maintain relentless pressure on German forces during campaigns in France and Italy. The tank became a tool not only of firepower but of operational psychology, allowing commanders to impose a pace on the battlefield that German forces struggled to match. These first four angles: human experience, tactical mobility, technological ingenuity, and leadership utilization, reveal the Sherman's multifaceted impact. Its endurance was not merely a mechanical feature. It shaped decisions, morale, and the very flow of combat. Yet the story would not be complete without considering the enemy's perspective and the psychological effect of facing a tank that seemed unyielding. For German engineers, examining captured Shermans was an exercise in disbelief. Accustomed to the meticulous design of Panthers and Tigers, they expected a medium tank to falter under prolonged strain. Yet time and again, inspections revealed a machine that remained operational, despite damage, mud, and wear. The suspension absorbed shocks, the tracks rarely derailed, and critical components were accessible for rapid repair. Reports sent back to Berlin reflected both admiration and frustration. A tank of such modest firepower can endure what our heaviest armor cannot. This revelation forced German engineers to reconsider the balance between complexity and reliability, a question that haunted late-war production and contributed to the logistical collapse of the panzer divisions. The Sherman's resilience also had profound psychological effects on both sides of the conflict. Allied crews gained confidence in their survival, often pressing advances where hesitation might have seemed prudent. Soldiers spoke of the tank that never quits, a mechanical reassurance in the chaos of battle. Conversely, German infantry and tank crews, facing waves of Shermans that seemed to reappear after damage, experienced frustration and demoralization. Even the threat of the Sherman could force strategic withdrawals, as commanders feared immobilized or destroyed positions being overrun by a continuously advancing armored column. The psychological momentum created by an unyielding machine became as decisive as any artillery barrage. Behind the front lines, the Sherman's design simplified supply and maintenance. Its gasoline engine was easier to refuel than the high-octane fuels required by German heavy tanks. Replacement parts were standardized across models, allowing units to cannibalize damaged vehicles without halting operations. Field workshops could perform repairs without heavy machinery, keeping tanks in action longer. In prolonged campaigns such as Normandy, this logistical efficiency multiplied the Sherman's battlefield presence, turning quantity and reliability into a decisive factor. Finally, the Sherman's endurance enabled new approaches to combined arms warfare. Infantry, artillery, and air support could coordinate more effectively with advancing tanks. The Sherman's mobility allowed it to adapt to changing terrain, follow infantry through obstacles, and maintain pressure on retreating forces. Commanders could synchronize advances across multiple units without fearing mechanical bottlenecks, creating an operational tempo that German forces struggled to counter. The Sherman became not just a vehicle but a backbone of Allied maneuver warfare. These angles together demonstrate the Sherman's influence on World War II beyond raw statistics. It reshaped human experience, tactical planning, engineering philosophy, and psychological warfare. The tank's enduring movement was not merely a mechanical trait. It became a symbol of adaptability, reliability, and the relentless momentum of Allied forces. June 6, 1944. Dawn broke over the beaches of Normandy with a gray, cold light. The air smelled of salt, smoke, and the faint tang of anticipation. Allied forces had crossed the Channel under a storm of artillery and aerial bombardment. Behind them, Sherman tanks rumbled across the landing zones, their engines straining against the sand and chaos. German bunkers bristled with weapons, but the Shermans pressed forward, undeterred by shell craters, overturned obstacles, and flooded ditches. It was here that the Sherman's suspension proved critical. Unlike heavier German tanks, which could become immobilized in the dunes and hedgerows, the Sherman's vertical volute spring system absorbed uneven terrain with almost uncanny resilience. Crews reported bouncing over shell-pocked beaches and through destroyed villages, maintaining speed even under fire. In one instance near Carentan, a platoon of Shermans advanced through a mine-littered field. Explosions tore earth into the air, yet the tanks remained upright and mobile, their tracks flexing and springs absorbing the impact. German forces watched in disbelief. Captured reports later revealed the astonishment of Wehrmacht engineers and panzer commanders. The tank continues forward as if the earth itself does not resist it. Attempts to pin the Shermans down with anti-tank fire were only partially successful. Damaged units often withdrew temporarily, only to return after quick field repairs. The relentless advance created a momentum German defenses could not counter, forcing units to retreat or be encircled. Beyond mobility, the Sherman's reliability allowed commanders to exploit breakthroughs rapidly. General Bradley coordinated multiple armored columns, using the Sherman's endurance to keep infantry, artillery, and air support synchronized. Tanks that could maintain operational readiness under sustained fire became the backbone of a dynamic offensive. Where German panzer divisions relied on careful positioning and ambush, Shermans advanced continuously, creating gaps in defensive lines and undermining the strategic balance. The psychological impact was equally significant. Allied crews gained confidence with each passing hour, emboldened by tanks that refused to stop moving. German soldiers, facing repeated breaches by a medium tank they had once dismissed, found themselves demoralized. Orders to hold positions became increasingly untenable. In field diaries, Wehrmacht officers described the chaos. "No matter where we strike, the enemy's armor returns. It is tireless. We are constantly reacting, never acting." The Sherman's endurance was not only a matter of mechanics but of operational philosophy. It allowed sustained offensive pressure, disrupted defensive plans, and instilled a sense of inevitability in Allied advances. Each crossing of a river, each breach of a hedgerow, reinforced a critical reality. The Sherman could outlast, outmaneuver, and outpace the German defenses. In the forests beyond Caen, Shermans encountered heavier resistance. Panzerviehs and Tigers attempted to halt the advance, relying on superior firepower. Yet even here, the Sherman's suspension and mechanical reliability provided a tactical advantage. Tanks could reverse, reposition, and continue the fight where German armor often required recovery teams for minor damages. Engineers who had once studied the Sherman on frozen fields now watched it in motion under fire, confirming their earlier assessments. The suspension system was a force multiplier, allowing a medium tank to perform like a heavy. It was within these first days of Normandy that the decisive lesson crystallized. The Sherman's movement was relentless not because of speed alone, but because of endurance under pressure. German defensive calculations, which relied on immobilizing armor through terrain and firepower, were proving insufficient. Every mile gained by Shermans expanded the operational reach of Allied forces, shortening the time for German reinforcements to react. As the Allies pushed inland, the combination of crew skill, mechanical endurance, and tactical ingenuity created a chain reaction across the front. Small villages, crossroads, and river crossings became nodes of strategic advantage. The Sherman's never-stopping characteristic was no longer an observation. It was a defining factor in the momentum of the campaign. By mid-July 1944, the Allies had consolidated their beachheads and were advancing toward Caen, a city of strategic importance in Normandy. German panzer divisions were massing for counterattacks, determined to halt the Allied push. Field reports described entire battalions preparing ambushes along narrow roads and hedgerows, confident that the heavier Tigers and Panthers would overpower the medium Shermans. Yet reality on the battlefield was starkly different. Shermans advanced with persistence that confounded German planners. Even when under direct fire, their suspension allowed them to cross bomb craters, debris, and uneven terrain without halting. At Rauray, a small village southwest of Caen, a mixed Sherman unit engaged Panzer IVs entrenched in defensive positions. Heavy German rounds hit the tanks, denting armor and damaging turrets, but few were immobilized. Field repairs were executed in minutes. Crews replaced tracks and repaired suspension arms on the spot. The tanks that remained operational continued to press forward, forcing German forces into improvised defensive maneuvers. German engineers on the scene recorded astonishment. The suspension system, which they had once casually examined in captured tanks, was now demonstrating its full potential. Each vertical volute spring absorbed shocks from terrain and shellfire alike. Tanks that would have been out of action for hours in the German inventory remained mobile. Commanders documented repeated patterns. Where one Sherman faltered temporarily, another would advance in its place, maintaining continuous pressure. The relentless movement created gaps in the German lines, disrupting coordination between infantry, artillery, and armored units. This mechanical endurance translated directly into strategic advantage. Allied planners leveraged the Sherman's reliability to execute synchronized offensives. Columns advanced along multiple axes, exploiting weak points in German defenses. In one notable engagement near Villers-Bocage, rapid Sherman movement allowed infantry to flank panzer positions before counterattacks could be organized. The Germans found themselves reacting constantly, never able to seize the initiative. The psychological impact on German troops was profound. Veterans of the Afrika Korps and Panzer divisions were accustomed to the careful management of armored assets. Tigers and Panthers required meticulous maintenance, and any disruption could halt an offensive. Sherman's, in contrast, seemed impervious to such limitations. Soldiers' diaries and after-action reports describe a sense of inevitability. Tanks that should have stopped, destroyed or disabled, continued advancing, forcing defensive withdrawals and eroding morale. Meanwhile, Allied crews developed an intimate understanding of their machines. They learned to exploit terrain, synchronize movements, and maintain operational momentum despite casualties and mechanical strain. The Sherman's endurance became a force multiplier. One tank immobilized did not halt the advance. The next one and the one after that kept moving. Commanders used this reliability to press assaults into areas previously considered too difficult for medium armor, expanding operational reach and tempo. By late July, the cumulative effect of Sherman persistence became undeniable. German counterattacks were repeatedly blunted not by firepower alone, but by the ability of Shermans to endure and maneuver continuously. Engineers, commanders, and soldiers alike began to acknowledge a simple truth. The M4 Sherman's strength was in motion itself. Its suspension, crew adaptability, and logistical simplicity combined to create a tank that defied conventional expectations of medium-armored warfare. The pivotal moment of the Normandy campaign, from the German perspective, was not a single engagement but the realization that Allied armored momentum could not be stopped through conventional means alone. Every attempt to immobilize the Shermans failed to achieve decisive results. The relentless forward movement of Sherman brigades forced German forces into strategic withdrawals, reshaped battle lines, and laid the groundwork for the eventual liberation of northern France. This convergence of mechanical ingenuity, tactical application, and human determination illustrated a fundamental principle of warfare. Endurance and reliability could outweigh sheer firepower when applied strategically. The Sherman, often underestimated at first glance, became an engine of continuous pressure, a force that shaped the course of the conflict not through isolated victories, but through sustained operational dominance. By the autumn of 1944, the consequences of the Sherman's persistence were becoming starkly evident. Allied forces had broken out of Normandy, liberated key cities, and were advancing toward the German border. The relentless mobility and reliability of the Sherman allowed armored brigades to sustain pressure over extended distances, a feat that heavier German tanks struggled to match. Supply lines were stretched, roads and bridges were contested, yet Shermans continued to operate in conditions that would have immobilized Panthers and Tigers. The German high command faced a hard reckoning. Reports from engineers and frontline officers describe repeated failures to halt Sherman advances. Even when engaged with superior firepower, German units were often forced to retreat or abandon fortified positions. The psychological effect on German troops was profound. Confidence in traditional armored tactics diminished as the tank that never stops moving consistently defied expectations. In some sectors, officers admitted that it was not the individual firepower of the Sherman, but its operational persistence that dictated the pace of engagements. Allied planning benefited enormously. The Sherman's ability to maintain momentum meant that infantry units, artillery, and air support could coordinate over greater distances without pause. Combined arms operations became more effective because tanks could be relied upon to hold positions or advance despite damage and obstacles. During the advance through France, the average Sherman unit could operate continuously with minimal downtime, outpacing German recovery and repair capabilities. Numbers reinforced these advantages. By late 1944, over 39,000 Shermans had been delivered to Allied forces in Europe, compared to significantly smaller numbers of operational German heavy tanks. While Panthers and Tigers outclassed Shermans individually in armor and firepower, the quantity, maintainability, and endurance of the Sherman fleet meant that overall battlefield presence favored the Allies. The tank's design allowed for damaged units to be repaired in the field, while German tanks often required specialized workshops or lengthy recovery operations. The strategic outcome was clear. The Sherman enabled sustained offensives, accelerated territorial gains, and forced German forces to adopt increasingly desperate defensive measures. Bridges were destroyed, villages abandoned, and counterattacks launched without sufficient coordination, all because the Shermans maintained continuous pressure. Their endurance disrupted German operational planning, forcing commanders into reactive postures rather than proactive maneuvers. This mechanical persistence was also reflected in post-battle assessments. Allied after-action reports frequently highlighted the Sherman's resilience as a decisive factor. In one account from the 2nd Armored Division, officers noted that Shermans, even when struck by artillery or mines, could continue to advance after rapid field repairs. German engineers confirmed similar observations in captured vehicle studies, noting the unusually simple yet effective suspension system that absorbed shocks, maintained track alignment, and reduced wear on essential components. The cumulative effect was more than tactical. It was transformative. The Sherman had shifted the balance in medium armored warfare, demonstrating that mechanical endurance, field maintainability, and operational flexibility could outweigh superior firepower and armor in determining battlefield outcomes. As 1944 drew to a close, the full impact of the Sherman's endurance became undeniable across multiple theaters. German forces, struggling to replace losses in men and machines, were confronted with a harsh reality. Their heavy tanks, while individually superior in firepower, could not match the operational tempo of the Allies' medium tanks. Supply shortages, mechanical complexity, and battlefield attrition meant that Panthers and Tigers frequently lagged behind Shermans in critical engagements. Engineers who had once studied the Sherman on frozen fields now recognized a recurring pattern: a simple, reliable suspension and robust, maintainable design could achieve results that brute force alone could not. German armored doctrine underwent a reluctant shift. Reports emphasized ambush tactics, concentrated artillery, and air support as essential measures to counter the relentless movement of Allied armor. Yet even with these adaptations, the psychological effect of facing Shermans remained potent. Soldiers described a sense of inevitability. Where German tanks had once been the symbol of armored dominance, Shermans now embodied persistence and resilience. This erosion of morale influenced strategic decisions, leading to cautious withdrawals rather than decisive counterattacks in many sectors of France, Belgium, and eventually Germany itself. The Allies leveraged the Sherman's endurance for sustained campaigns across Western Europe. Rapid advances through liberated territories allowed infantry, engineers, and armored units to maintain synchronized momentum. Cities that might have otherwise required prolonged sieges fell under continuous pressure. The Sherman's ability to operate after minor damage, traverse challenging terrain, and return to action quickly meant that attrition worked in favor of the Allies. Every repair completed in the field translated into renewed offensive capacity, compounding operational advantages over time. Statistical records highlight the scale of this advantage. By December 1944, over 50,000 Shermans had been deployed across Allied forces, compared to a few thousand operational German heavy tanks. Losses among German armor were increasingly catastrophic, not only because of firepower, but due to the inability to sustain continuous operations. The Sherman's mobility and mechanical reliability allowed the Allies to project armored power in ways the Germans could not counter effectively, tipping the operational balance and hastening the collapse of fortified positions. The lessons of the Sherman's persistence extended beyond individual battles. Military analysts noted the importance of maintainability, standardized parts, and operational endurance in modern armored design. Future post-war tanks, including American and British models, incorporated these principles, emphasizing mobility, reliability, and repairability alongside firepower. The Sherman's success demonstrated that engineering philosophy could directly influence battlefield strategy, morale, and the broader conduct of war. In the human dimension, the psychological imprint of the Sherman endured. Allied crews took pride in operating a machine that rarely faltered, while German troops carried the memory of relentless, seemingly tireless opponents. Memoirs, diaries, and post-war studies recount the awe and frustration that the Sherman inspired, capturing the essence of a tank that was far more than its specifications. It was a testament to the interplay of human ingenuity and mechanical endurance. By the winter of 1944, the operational and psychological consequences were clear. Shermans had enabled the Allies to sustain advances across Western Europe, undermined German defensive strategies, and forced a re-evaluation of armored doctrine. The realization that a medium tank, through endurance and reliability, could dictate the pace of campaigns became a defining lesson of World War II. The story of the M4 Sherman is not one of sheer power or technical superiority. It is a story of endurance, resilience, and the subtle genius of design applied to the chaos of war. Across frozen fields, mud-choked villages, and shattered landscapes, the Sherman proved that movement itself could become a weapon. Its vertical volet spring suspension, simple yet remarkably effective, allowed it to traverse terrain that immobilized heavier German tanks. Crews trusted it, commanders relied on it, and enemies came to fear it, not for the force of its cannon, but for its relentless persistence. History often remembers decisive battles and spectacular victories. Yet the Sherman teaches a quieter lesson. Reliability and consistency can shape the outcome of a war as profoundly as raw firepower. Each mile it advanced, each obstacle it overcame, imposed a tempo on the battlefield that German forces could scarcely match. Engineers who once examined the tank in idle curiosity came to understand a fundamental truth. The design philosophy of simplicity, maintainability, and endurance was as formidable as any heavy armor or high-caliber gun. The Sherman also embodies the human dimension of warfare. For crews it became more than a machine. It was a partner in survival, a vessel of confidence amidst chaos. For commanders it provided operational freedom, enabling tactics that relied on continuous pressure and coordinated advances. And for opponents it became a psychological symbol of inevitability, the reminder that some forces cannot be stopped by power alone. Ultimately, the M4 Sherman reshaped armored warfare. Its legacy extends beyond World War II, influencing tank design and military thought for decades. It reminds us that engineering philosophy, human ingenuity, and endurance can combine to create machines that define history, not merely through the battles they fight, but through the momentum they sustain. In the frozen fields of northern France, in the hedgerows of Normandy, and in the hearts of those who faced it, the Sherman's lesson remains clear. Persistence, reliability, and adaptability can move the world, 1 mile at a time.